try and give you all a bit of an overview of some of the products information that we make, and give you a little bit of background, I guess, into the uncertainties and details about those. Next slide. All right, I just have a few slides of basic water level 101. I think we have a pretty Great Lakes savvy group here, so I'm not going to spend a lot of time here, but you know, just again, for reference, when we're talking the Great Lakes system, we're talking all of the Great Lakes from, you know, the very top of the system, Lake Superior, working your way all the way to the Great Lakes outlet down the St. Lawrence River. And, you know, a couple of things to point out here. You know, we've got this very large natural system. We do have 2 points throughout the Great Lakes where we actually do control outflow from one lake to the other. So that's the outlet of Lake Superior down the St. Mary's River, flowing into Lakes Michigan and Huron. And then also at the very end of the system, at the outlet of Lake Ontario, down into the St. Lawrence River. So I'll discuss what that means from a forecasting impact. But again, you know, I guess one of the key takeaways that I'll hit again is just with this very large basin, very large natural system with some points of outflow, but ultimately water levels are a product of what kind of conditions Mother Nature brings into the system. Slide. All right, some other basic concepts when we're talking water levels. So much of the information, products that I show are based on lake-wide average water levels for each of the lakes. So if I say the water level of the Lake Superior, the water level of Michigan and Huron are this, those are each made up of average of a network of gauges across the US and Canadian portions of that lake. So we have highlighted here, just for your awareness, the various locations of the water level gauges across the Great Lakes, with the bigger dots being those that are actually used to come up with the lake-wide average level for each of the lake. We'll typically be talking about water levels on a daily average time step or a monthly mean. But again, we're talking about an average still water elevation, which obviously, you know, that actual local water level will change drastically depending on where you are at the lake, you know, wind and wave conditions and all that. But for the purposes of what I'll go over, I'll stick to kind of the higher level, longer term, you know, lake-wide average levels for each of the lakes. Slide. And then the other basic concept, again, you know, I mentioned how the Great Lakes water levels are really driven by natural conditions. And specifically what I'll talk about and I'll show information about is a term that we call net basin supply. So when you look at, you know, the water balance of each of the lakes, you're typically going to have water flowing in from the upstream lake. You're typically going to have water naturally leaving down through its outlet. But then we have this term called net basin supply, which is the sum of what the water that Mother Nature is bringing into the lake. And that's the amount of precipitation that falls directly on the lake surface, the amount of water that runs into the lake from the watershed around it, and then the amount of water that's leaving the lake through evaporation off the lake surface. So when you put those together, we call that term net basin supply, and that's, again, an important term that is going to be the dominant driver of the water level fluctuations that we see. All right. Now I'll start drilling into some of the information we have available. I'm really going to focus my talk here on some of the kind of the longer term data sources and forecasts that we have. I think later in the week, my lead forecaster, Deanna Apps, she'll start talking a little bit more about some of the more shorter term local conditions, but I'll stick to again some of the longer term data sets here. This is just a highlight of our website. If you haven't been there, you can see the URL circled at the top, along with you know, where you'd go if you click on that water level link. That drills you down into where most of our products are buried in some fashion. Next. After you click that water levels link, this is where you get to. So we have again a wealth of information about water level conditions, you know, current levels, historical levels. We have information about most of the the different net basin supply components that drive water levels. So again, I'm not going to highlight everything we have here. Certainly encourage you to take your time to kind of peruse what we keep updated there at the website. But I'll at least show a couple of key products to make sure you guys are aware of those. Next slide. So one of the things we do is monitor for long-term trends in conditions throughout each of the lake basins. So I've pulled a graphic that we update annually for Lakes Michigan and Huron to give you a little sense of what you're looking at here. Those on the left are the precipitation, the evaporation, and the runoff into Lake Michigan, Huron. We have plots that we've broken out by month so that you can look back from 1950 to present and get some idea of, are we seeing kind of seasonal changes where maybe we're starting to see certain months get wetter while other months get drier. Maybe we're starting to see evaporation starting off earlier in the season than it did. So, it's something we update annually, periodically do a review, again, looking for long-term trends. Can you all hear me? Looks like my screen is hung up a little bit.
Hi, John. Yeah, we can hear you, but your video did disappear.
Okay, good. Well, I'm sorry about the video, but I'm glad you can hear me. Okay, and then on the right side of the screen, what you can see are annual plots. So we have each of those components just plotted annually so that you can, again, look for long-term trends across the basin. And again, which is important for us to understand how things are changing, how we may be responding due to potential climate change, other impacts. I guess spoiler alert here for Michigan Huron, not a whole lot of obvious noteworthy trends, although the evaporation is the one thing that has stood out that over the last 30, 40 years, we've generally seen an uptick in evaporation. But again, encourage you to look at this information. We have these broken out separately for each of the components and each of the lakes on our website. All right, next slide. And since my WebEx is frozen, I likely, it's not going to tell me. Can you, is this the long-term hydrograph slide?
Yep.
Okay, good. All right, well, I guess I've seen this slide many times. I can talk to it. So again, this is another product that we keep updated. You've probably seen this a bunch of times, but again, important to try and keep the long-term, keep water levels on the Great Lakes in long-term context. So what you see here are the monthly means plotted over our period of record for each of the Great Lakes. So you should be seeing a blue line that's kind of going up and down, and you're seeing kind of the seasonal pattern of each year of water levels for each of the lakes. There's a line for the long-term annual average to put in context of when we are seeing higher or lower periods of water. But it's helpful, again, to understand, if you look all the way on the far right and you see how levels have responded, very quickly or rebounded very quickly here recently. And again, all the way up to the record highs that we've been experiencing this year. You look back across, the coordinated record here, and you'll see that although we're at record highs, they're similar to record highs we've experienced previously, back in the 80s, the 70s, the 50s. Again, kind of keeps in context that water levels on the Great Lakes do fluctuate between high and low water periods. Roughly have been in the same historical range for quite some time. And also, as we do cycle through these periods of high and low water, there's no obvious set, amount of time you can really predict. You can't go back and say, oh, geez, we always spend 20 years above and then 20 years below and then 10 years, you see that we certainly do cycle between these high and low water periods, but they do vary quite a bit in length each time. And from a forecasting and prediction point of view, at this point, we really can't ever say, oh, we expect to be above average or very high for X amount of years, because that's just what the pattern normally does. At this point, we just don't have those kind of clear signals for us to be able to use looking forward. All right, next slide. Now my memory runs out. You're going to have to remind me what slide I'm on.
This is uncertainty in water level forecasts. You've got a couple of plots. Yeah.
Okay, yeah, so I showed water levels and conditions. Now I'll talk a little bit about our forecasting products, but I just wanted to kind of discuss forecasting a little bit as far as what we know and don't know. So when we create a water level forecast, there certainly are some things that we do know, that let us start putting together a forecast. We certainly know the current water levels for each of the Great Lakes, which is important, especially as you kind of work your way through the system. If we're forecasting levels on Michigan Huron and we know levels are high on Superior, it's going to cause a residual amount of time of higher flows, being released out of Lake Superior down into Michigan Huron. We also know, kind of general basin conditions currently, that lets us help us have a starting point. We also, we know what the Great Lakes systems are physically. We have, we understand how much water can flow through the connecting channels, the size of the Great Lakes. So we have models put together that let us route the supplies of water that we expect to see in the system coming up, and route those through the system in a physical way to come up with the forecasted water levels. Obviously, the kinds of things we don't know, are those forecasted conditions. When you think about, the components of the net basin supply, so understanding precipitation, runoff, and evaporation, we certainly have products available from other agencies to help. When you're looking out in the short term, I think I included, the 7-day QPF, and certainly this week, expecting a lot of moisture to be working its way through the system. So when you're updating a shorter term weekly forecast, that information is helpful. Once you start looking out to produce a forecast 1 to 6 months out, so we're trying to get further out, we start to get much more limited data available. I included, I think it was the 3-month CPC outlook, to give you an idea of, precipitation and temperature anomalies expected. And I think the precip was just equal chances, and my memory fails me on the temperature. But again, we have very limited information, very uncertain once we get that far out, which makes it difficult for us to piece together a forecast, to expect really wet, really dry, or other conditions. So, and then certainly when we start looking even further on, people want to know, well, what is climate change going to tell us about the Great Lakes? That's even more difficult at this point. Although there's ongoing research, there's not a clear signal one way or the other. I think coming out of the Upper Lake study 10 years ago or so, the scientists were starting to think maybe there was a slight signal for lower levels. I think now maybe it's a slight signal for higher levels, but generally the consensus is still that we expect to be fluctuating between high and low water periods, similar to what we've seen historically. So again, when we're trying to predict what's going to happen next year, 2 years, 5 years, there's very, very limited information to look out that. All right, next slide. Is this forecast for Michigan Huron?
Yep, and you've got about a minute or two left, John.
Okay, all right. Well, then I'll kind of hit this, and then I can move on pretty quickly. So you all are probably pretty familiar with the forecast plots. This forecast of Michigan Huron. This is our primary product, looking out 6 months for each of the Great Lakes. And again, just focusing on Michigan Huron here. The red line looking out, kind of starts from, I think, about 2 years ago and moves to current, and then it moves into this forecasted band. So it gives you an idea, is that band is our 90% confidence interval. So you see how wide the range of uncertainty gets as you start to get 3, 4, 5, 6 months out. So really, when people use this product, although there's a most probable line in there, it's maybe more useful to get an idea of the range of possibilities. If we get really wet conditions, we would expect to be near the top of the band, really dry near the bottom of the band. So it may be more helpful to understand the range of possibilities looking out 6 months out. You can skip through the rest of the lakes. Again, there's good information here. It gives you an understanding of current levels and forecasts and the records that have been set. But if you can go to the 12-month outlook, that's really the last slide I need to talk to.
Okay, were there?
Okay, so this, I wanted to make you all aware of this product because we get asked quite a bit, well, 6 months is great, but what about a year from now? What are water levels like? And I want to be clear that this is not a forecast, but we do put together this outlook looking out over the next 12 months to give you an idea, kind of from a what if perspective, what could happen to help from maybe more of a planning perspective. And so what I have here is the one that we completed in October. And what we did for this product is we, knowing that we're starting to go into a La Nina winter, we went ahead and pulled information of previous years where we had strong La Ninas and took the supplies from those years and use that in our forecast model here to see what the resulting water levels would be. So that pink range shows the range of all the previous years that were La Nina years, and it gives you an idea of kind of the range of outcomes that we could expect to see if we followed similar years to those previous La Ninas. We pulled out 2 of the stronger, most recent years that had La Nina as well, and plotted those specific sequences there. So you can just see what would have happened if we followed. So again, useful from a planning perspective if you are trying to understand what could happen and the range of possibilities, but would caution you that that's certainly not a forecast in the sense that our 6-month forecast is. So I know I'm short on time. I think that was my last slide. So again, buried a lot of information in this presentation. Hopefully over the next couple of weeks, you have a chance to check those out, and we can start talking about those more in some of our breakout sessions. Well, thank you.
All right, thanks, John. We did get one question for you, and this comes from Jim Anderson. He says, looks like Lake Michigan has larger variation than the other lakes. Do we know why? And I believe this question was raised when you were showing those long-term time series hydrographs.
Yeah, so especially when you compare it to Lake Superior, but yeah, so that's mostly a product of just the physical characteristics of the lake itself. The Michigan and Huron are essentially one large basin together, so very large surface area, drainage basin. So we tend to see more variability in the water supplies. The outflow regulation on Lake Superior does have a little bit more of an influence on Superior's level than it does Michigan Huron in helping to eliminate some of the extremes, but mostly just a product of the physical characteristics of the basin.
Okay, thanks. If anyone else has a question, again, feel free to type that out or raise your hand. But I think this might also be a relevant time. I just want to plug that coming up on Monday, November 2nd, there's actually a webinar, a Great Lakes Climate and Water Levels update. So this will give some information on where water levels currently stand, how we got there, and also an outlook for the winter and spring. And John, I believe you are a panelist. So if you have anything else you want to say about this webinar, go ahead, but I can also send out the information to the group.
No, sure. I'll get much more into the details of forecasted conditions and what we've been experiencing there. So, yep, it's I think the third of a series of webinars that we've been doing to update throughout the season. So, forward to talking to you, some of you there too.
Oh, let's see. One other question. What does QPF mean?
What is it? Quantitative precipitation forecast. Am I getting my?
I think that's right.
Correct. Okay. Thanks. But or cumulative, whatever. But yeah, essentially that's a product that gives you an idea of the amount of precipitation that you could expect to see, and I think it starts looking at 1 day up to 7 days out. So good idea of the amount of moisture that may be forecasted to come through a region over a set amount of time.
And one more comment that just came in. As you mentioned, USACE can regulate flow through the locks from Lake Superior, which results in more water in Lake Michigan, Huron. Was this the catalyst for this, and how is it decided? How much is it let through?
Oh man, okay, I will try and answer that. That's a long conversation itself. So, so no, the catalyst was just originally when the Sioux locks were built. Well, actually, back I think it was that the hydropower entities that built there originally, when they applied for their permit between the two countries. It's just part of the conditions of their operations. Was to, I guess, set up a management plan for the levels or for the outflows from Lake Superior. And without getting into all the details, essentially the regulation happens underneath the IJC through an international control board, and it essentially mimics what the natural conditions through the river would have been before all of the locks and structures were built at the Sioux, while also trying to balance extreme levels on Michigan, Huron, and Superior. So could get into a lot more detail, but now I'll leave it at that.
Okay, thanks.